nowadays it is growing very rapidly, robotic things. So why we will use these embedded systems? Why they are used in? So what are the crucial several reasons for this? So why embedded systems means there will be a efficiency. So efficiency means, so you should do some particular work in the perfect manner. So if it is a 100% work, you should provide the 100% efficiency for any work you have to do. So suppose if you want to some suppose if you see any security systems, like if you want to allow a person for the inside any of the systems, so there will be a no malfunction of the any functions. Like if you are using another one's ID card and you want to malfunction the particular card, and you want to use that card with the for the another person, like there will be a security reasons for the um, most of the embedded things. So cost effectiveness. So cost effectiveness, why where this cost effectiveness will come means, there are the embedded devices are there, so most of them we are using the microcontrollers or processors. So when we compare to the FPGA devices, we will use the microcontrollers. Why? Because FPGAs are more faster than the microcontrollers, as you know. But still, we are using microcontrollers and microprocessors. Means, so most of the them we might not need that much of accuracy or that much of speed we have. So if you do if you do your biometric means, it will take us some 1 second time, or below 1 second only it will do. So those kind of things will be done by the embedded systems. So those kind of accuracy and time management is not required. Wherever there is a wherever there is a some time, there is a no time limit for the particular system, there we can use this cost effect microcontrollers and microprocessors instead of. So these microprocessors and the controllers are very less cost compared to the any FPGA devices. So real time performance. Real time performance means, like so there will be a in controllers there will be a multitasking will be there. So if you can hear like a multi-core process. Like if you buy any phone, there will be, they will say it is a 8 core processor, 16 core processor, 32 core processor, 4 core processor. There will be like number of cores will be there increase. Like if you do one task in a single time, they will do so at a time they will do a 4 tasks at a time. So that will increase the performance of the any systems. So okay, let's move to what generally embedded systems will do inside. So what is mhm, okay, what embedded systems will do, like so as I say, it will monitor and record. So suppose if you say take your smartwatch is an example, it will monitor and record. So it will monitor your steps and everything, heartbeat, everything it will monitor, and it will record in your some storage. So actuate means some move or release. These actuate command, so it's not for the your watch or any. If you take some automotive car, you can take self-driving cars. So if you take some self-driving cars, there will be some sensors in front of the car. So in front of the car, so if you always it will monitor whether in front of there is any pedestrian in front of the car, or any moving car in front of it is very nearer to you, or else how much speed you can maintain. Those kind of things always it will monitor, and it will record every detail for that, and it will activate your in, so like a speed control accelerometer, like a after that. So it will increase, based on that it will increase or decrease your speed. That is what actuate. it will control some control engine, and it will increase speed based upon your data. So alarm, shutdown, or emergency action. So suddenly, if you're moving in a self-driving car, you give your so you give your control to your car, and it is automatically it is running, it is monitoring whether in front of there some car is there, some people are coming, and whether there is a signal, a red signal is there in front. So always some cameras will be in front of some cameras will be there, some sensors will be there. So it will always cameras will be do the some image processing for the these signal kind of things. And if any people are coming, some proximity sensors will be there, some ultrasonic sensors will be there. Those sensors data we will take, and we will take any emergency, like some people are coming in front of the car, means it will take immediate action, like it will press the automatically, it will take the brakes, and it will reduce the speed, and it will put brakes. And control access means so if you want to reduce any speed or something, so it will automatically it will control. So deliver content. So deliver content means, so whatever the data, whatever the speed you are going, and it will automatically show in your display. So like in a digital screens, if you see your bikes also, you might see some data. So this 40 kilometers per you are going, and 50 kilometers per hour you are going. Those kind of content it will deliver to any systems, either your display, or else if you connected to some, even you can connect to your smartphones, or also we will connect. So those kind of data we will deliver to that. Communications is a lot of communications. So if you deliver these kind of data, means there will be definitely some communication medium should be there between some embedded devices. So what are these communications, I will discuss it later. So like if you see normally, if you see some communications means Wi-Fi, Zigbee, Bluetooth. So mainly you can see all of your cars, and all those things communicate with the Bluetooth. So translate, decode, interrupt. So embedded systems. So what is this translate, decode, interrupt means? Some embedded devices will send data in an analogous manner. So some controllers will take a analogous data, and it will convert to the some digital format, and it will connect to digital and it will deliver that content to the whatever the device it required. So decode means some you have the some algorithms, like inside some security data if you send, means there will be some inside some algorithm should be they will encode it, that should be decoded inside the microcontroller, means some embedded devices you can say. So this is all what embedded systems will do. So let's see in industries how they will develop any embedded devices. Like if you see if you have any project, like they will say projects, like we are designing some particular battery monitoring systems we are doing, like say security control systems we are doing, like some access controls we are designing. Some project names they will tell, like we are doing some project means nothing like it is like they are preparing some hardware and some code. Firmware means it is a coding whatever we are doing. What is a firmware and software means? Like a firmware is like a we are dealing with some hardware, and we are writing a code for particular that hardware, that is a called a firmware. Software means there is a no dependency with the particular hardware we are running. So software means there is a no dependence on the particular hardware. So firmware is like a coding only. Hardware means some embedded device we are making, so with a lot of sensors and controllers, we are actuators. So we are designing some embedded devices. So how they will get the project? So some of them have the requirement of like some battery monitoring systems. I want to build some, so we have a large amount of batteries to for the backup or something. So I have to monitor a particular battery backup system. So and monitor, and I have to charge my batteries based upon whenever they have fall down for under some voltage. So I have to control those things, and I have to monitor those things. So they have a requirement like the purpose of the systems. Oh, what is the purpose, or what you want to do? So that is a basic question from this will give from the customer. Who are all the customers? The customer might be any of the other companies, or as any of the outside persons, like if you are personal things also, you can some personal. So most often they will be companies will be there, so they will buy these kind of things. Even households also we will use these things. So so I want to monitor the batteries. So define the requirements. What is your requirements? Like I have to monitor my battery's voltage. So each times whatever the voltage I am charging, so if it is charged full 100%, if you see your phones, if after 100% it won't stop, it will still be charged in that charge state only. So it will not stop. If you keep on charging like your phones, someday your battery performance will be low. Why? Because battery should not be charged like this. Okay, whenever when you reach a particular voltage, you should stop the charging, and whenever it will come to some particular low level, and you have to start again your charging. Is below 10%, I have to you have to charge my battery. So whenever there is a after 95% or 100%, you have to stop charging of my phone. And always you should monitor my battery voltage things. So whatever the current battery voltage, you have to display always what are the voltage I have. So these are the basic requirements. So there will be a technical specification. Technical specification means like so how many batteries you have, so how much big your system, like how many batteries you have. You have 10 or 10 batteries, 100 batteries, or you are a you're the large industry, you have to monitor a 100,000 kind of battery systems. Those kind of things will be considered here. Technical specification means so how much big your system is. Unless graphical interface. So you need any, like if you monitoring a 150 batteries means, if it is damaged means you have to tell that some particular battery is damaged, some particular battery is not charging, some particular battery is uh, it is not it is even charging, but the that particular power is not delivered even it is a full. So those kind of status, graphical status means whatever you see in your phone or whatever you see in your laptop. These are all kind of a graphical interface. Create a prototype. So once you fix your requirements and all, then you will prepare some prototype. Like so I need to monitor the systems. So for that I have to read the voltages. That means you have to measure the voltage of every battery. So how you can measure? So what are the hardware required for the particular battery monitoring system? So is there which controllers you have to use for that to measure the to measure the battery voltages? So what are the other kind of interfaces you have? So suppose you have to send this data to some graphical interface. So you want to send to your phone, your laptop, so through ethernet or through Wi-Fi, through Bluetooth. So if you want to interface those things, some Bluetooth, Wi-Fi, so those kind of embedded equipments you need it. So for those kind of things you need some prototype for that. So what is the basic architecture? So build a system architecture. Like system architecture means it will be a combination of hardware and both firmware. I mean coding. So there will be both will be there. So you have some hardware architecture will be there, and there will be a coding architecture will be there. So whatever you want to build, and then operating systems. So these operating systems will I will not cover now, but it is like a OS kind of things. You are using a Windows means not kind of Windows OS things, like whatever embedded devices you are using. So they are using some OS kind of things like a RTOS. You can hear some names like a RTOS. Those kind of things will be there. Real time operating systems. So, yeah, what are the use for this operating system? Means like it will run the multitasking. It can do multitasking. Some of them, if you're not using some operating system, means cannot do multitasking. It will do a single task at a time. So this is what mainly use of this operating system. So basic architecture they will build. After that, this is the overall system they will initially design. So, anybody have any questions? I can move. Okay. So I know this is some high level. I will just giving a brief introduction, like how if you go to any industry, like they will basically start with the you can do some work yeah, they will give some controller and read the data sheet and do some work like use this peripheral and connect to some Bluetooth module and take data from that particular module and send that module. There is small tasks they will give, but if you go to the any big industries like some MNCs, if you go, they will mainly will follow the process will follow. They will simply don't tell do this, go and take some controller board or take some Arduino board. You have, I think most of you see the Arduino boards for your projects. So if they will simply don't give their board and do this yeah, on some LED, blink some LED, or else control some kind of some motors. Those kind of things will not be there. So they will follow some process. So from the any small works or big works, they will always follow some documentation, some procedure they will follow. So I'm giving a say very brief introduction on these things. So these are all. Don't be confused. I will end up with your whatever you need at the last. Okay. Okay, these and all I will mostly skip. So like if any it is like for coding, so you have to gather requirements whatever I told for battery monitoring. You will gather requirements and you will do some analysis like which type of code I have to write, like in which language I am writing, like a C code I will use or assembly code I will use. These kind of things will be there, and so basic prototype, and you have to submit some code pseudo code type like so in paperwork, this will be some paperwork like I will do coding like this, and I have some application code, and so I have some peripheral code like this. Some analysis will do, some design you will tell this many functions I'm writing, and this many application this much application code I have, and it will consume this much memory of data from the controller. Those kind of things will here, and you will do coding here, and you will test that code. Every code you have to test, and there will be a integration testings will be there like so there is a in industries there will be there is a no single works will be assigned like if you doing any project and if you're doing any project, there will be at least 3-4 members will be there. So in big industries there will be 10 to 12 people will work on this. So multiple people will under work on this coding, so they will develop individual codes, but ultimately our task is simple one thing only. So monitor some battery monitoring systems or any cruise control system, those kind of things only. So they will integrate all the code and they will test, and overall hardware. I think someone should be mute. I think Nageswara, you can be mute. Okay, thank you. So there will be a system testing will be there, and after that acceptance testing means it will be, and it will be go to the some customer and he will test the embedded device and he will send back to some feedback and some modifications. This is what the development cycle. I will move forward. So there, so what are this is the embedded basic system architecture. You are seeing some diagrams, but actually it will be like some controllers will be there. So like a central processing unit means this is all some controllers will be there. So this embedded system totally it will come with some controller like some controllers will be there, and along with that some analog input output will be there. So digital inputs will be there. So most of you, if you know or not, I don't know, but you're doing some LED controls and all will be there, right? So most of them, those are all like a digital IOs only. Those are like ones and zeros you will control from the controller. So those are all like digital IOs. some counters and timers. So if you want to do so particular every 1 hour, you if you want to do some control some motor, or if you want to do on and off the some light with the morning, night in evening 6 o'clock you have to on the light, and morning 6 o'clock you have to off this for the those timings and all. So I'm giving some basic. So those kind of timings you need. So for that, some timers inside the controller only we have some timers will be there, some controllers will be human machine interface. So we have LCDs will be there. So if you enter some keypads, if you see not so if your system keypad is somewhat big, if you see some if you see at your biometric, if you have or not, I don't know, you can enter some pin. For the pin you have some small keyboards with keypads will be there, only numbers will be there. So those kind of things also human interface only. Some LCD displays also, small LCD displays will be there. Those are all embedded system. So embedded systems mainly main heart of the embedded system is some the whatever controller you are using, uh, that is the heart of your, it is like your brain, like so whatever you want to do, so only controller should do. So no motor will not do anything, and any sensors will not do anything alone. So whatever you are doing, that is under the control of this microcontroller only. So for that only, so you have to mainly focus on the things of a microcontrollers, what it is to do, what it will do. So whenever you have some hands-on practice only, you will better know these kind of things. So CPU. So whatever I said, inside microcontroller there will be a processor and there will be some memory like a RAM, ROM, flash memories will be there. So CPU is like a processor, microprocessor. Every microcontrollers inside some processor will be there. That will be like a ARM processor will be there, like NXP. They have their own processors. So they have some architecture, like it will be like a 32 or 1632 bit. Based upon that architecture, every individual processor have their own instructions will be, instruction sets will be there. So based upon that we will write our code. So if you see here, CPU, memory, input and output. So this memory is used for our code. You have, if you write any code, that will be stored in this memory. So whatever the input or output. So if you see some sensors data, so it will take in sensors data and memory. Memory it will to some memory, and CPU will access that memory and do some processing of that particular data, and it will keep it on same memory. And if you want to if you have any communications, like if you see the below diagram, so CPU, RAM, this is program memory, and some transducers means you are controlling keypad, screen, UART, parallel. These kind of things are these are external communications you can use. Like whatever the data you are processing inside the microcontroller, if you want to send to the outside of the any devices, there will be some communication that are UART. So these peripheral communications you can see after this session. You can once see these things. Go to any embedded industry, or if you want to do anything. So main thing you have to learn is a these controllers things. Like a controller, what are the peripherals? What is the peripheral? What are the this kind? What is the RAM? What is ROM? What is control and instructions? How we can write code to any controller? These kind of things you might know in your level, at your level, initial level. So this is what inside some controller. So this is, if you see, this is total, it is a controller. It is a packed. It is a packed one. Controller is a packed one. Inside that, you see the processor. Processor is like a logical thing. It is like your calculator. If you give 5 and 6, it will give the, if you give add means it will give 11 number. Though so processor is like a some if you give some instructions, then it will give output for the particular instruction only. So nothing will do. Nothing it will do. So all the things are outside only. So if you have this flash memory will for, I said you, for code. It is for while running the code. If you have data, those data will be stored in cache and SRAM. So this is the peripherals we will call. Peripherals means some sort of communications or any analog or digital interfaces. Like if you have any what the sensor, gas sensors will be there, like smoke detectors will be there. For that particular sensor, if you need any data, those kind of things we can interface through these ADC, UART, SPI, I2C, USB. These all things they will say as a peripherals. Whatever the outside of this arrow, these are all come under as a peripherals. They will called. I'm saying the terminology. Slowly you will habituate with this. Because most of you know, at this stage, I don't know even this. What are the peripherals? What are these controller? I even don't know. Just I'm giving a very low level introduction. So these are communication. UART, SPI, I2C are communications. Like if you want to talk with any other controller, if you want to talk with any outside of the device, these communications only they will use. So even if you want some Bluetooth also, so for that Bluetooth, they will have some SPI communication. So or else UART communication. That Bluetooth device will communicate with these, and through wireless inside that some RF technology they will build. So to wireless, they will connect to your phone or something, anything, any device. So this is what mainly inside controllers. Okay, then challenges before development. So if you take any industries, if you want to develop any system, so initially they will choose for what is the programming language I have to choose. Like will I write in assembly, C, C++, which type of code I will write. So and then they will choose some hardware platform. So what the hardware I can choose, like what controllers I can use, what are the communications things, even Ethernet I can use, or a Wi-Fi I can use, or any RS-232. These are all like communications. Like even on that also there is a difference. Like it is a wired communication I need or a wireless communication I need. These kind of things will be there. And software platform. So software platforms means coding, where you will code, where you will write your code, how you will write the code, how much big your code. Those kind of things will come. Like what are the staff. So they will recruit some people to do these works. Like even firmware or hardware, they will recruit some people who are the knowledge of physics and electronics. Most of the electronics people they will recruit. So decide deployment. If you start any project, they will definitely there will be some deadlines will be there. So you whenever you start working on anything, so choose some deadlines. So I have to complete this work by at least this date. The deadlines will be there any deployment. So you have to commit for the particular customer, then you have to submit that your project to particular date. Some maintenance works. After delivering your product also, there will be so much maintenance in your work. So it is not about a you simply say they give some requirement about your delivering product, not that. So there will be always some maintenance works will be there always. So what are the initial I said it is a combination of hardware and software things. So what are the hardware things? So like I said, the brain of the system, embedded system, it is a microcontroller, a microprocessor we are using, and some memories, even that is a RAM or ROM, some actuators. Actuators means whatever you're controlling, some motors, all things. What are the motors you're controlling? Those and all sensors, all the sensors list I have in front. I have the sensors list. So inside firmware means it is like controlling your inside controller. Firmware means what? Nothing like inside some controllers there will be some registers will be there. So you are writing code for the particular register, for controlling particular register and accessing some particular address. These kind of things will do by the firmware. Application code means as I said, application code means if I have a requirement like yeah, the battery is below 10%, I have to charge my battery. These kind of things, decision making things will be in the application code. So as I said, there will be hardware sensors in the hardware. So those kind of things like LDR sensors. These are LDR sensors, IR sensors, like for daylight, for light dependent resistors. Like these are for like you detecting some day sunlight, or it is a moonlight, it is a day or night. Like for detecting IR sensors will be there, gas sensors, smoke detecting sensors will be there. So ultrasonic sensors, these will be send some sound waves, and it will, whenever it will reflect from the any object, it will hit, it will reflect those waves, those kind of stuff. This will measure when in front of your sensor, if any object is there, it will say, measure the particular object is at some 10 meters distance, particular object is at 500 meters distance. Those kind of sensors will be there, like if you, they can use in cars and all, in front of the car, any self-driving cars. So heartbeat sensors you can use wear in your smart watches. Touch sensors you are using in the phones or watches also. PIR sensor, soil moisture. So this soil moisture we are using in our agriculture things. So temperature sensor, mostly we are using these temperature sensors. Like even they are using for monitor our daily temperatures, like and actuators you can see. Actuators, what are the actuators means? Whatever we have, so you want to control some motors, fans, lights, air conditioners. So if you see what are the controllers we have, so at your level, in our case, we will see the most of you will see the 8051 controller. I think you might see, and some processors 8086, 8085 processors you might see uh, in your B.Tech studies. But these are outside. There will be some much more controllers will be there. These are the controller providers like STM32, LPC, ARM, NXP, Atmel. These are the controller providers. These are the companies, they will provide controllers for us. So based on your requirements, from low budget to high budget, they will have some high performance. Based on the performance, they have the cost also, cost of that controller. So memories. So inside the controllers, there will be some memory. Apart from that, if you need extra memory for any of the things, you have to buy from external. Those kind of things like RAM, ROM, NAND, or flash memories. So they will store. So volatile, non-volatile means RAM memory. It is like whenever you have RAM memories means it is a permanent memory. So RAM memory means it is not a permanent. Whenever you switch off and on, that memory will gone. Whatever the data inside that memory, that will vanish. Okay. So inside firmware, what we have? So like inside firmware or application code, what we have? Like firmware means mostly what we have means programming will be there, like a C code or assembly code, logics. So for the any application, for any of the things, you have some logics will be, you will generate. So if I say some find the largest number in a array means, so you have come with some 2 3 methods, like some of them will do will use some for loops, some of them use some while loops. Those kind of things, logics will be there. So problem solving. So even though if you're writing a large bulk codes, even if you might see the syntax errors will be there, like. So those are all will be solving those problem solving of those things. Data handling, if you are reading sensors data, so you can have to read the bulk data, and sometimes you have to maintain that data, like past 30 minutes data I need to maintain in some memory. So those kind of data handlings will be there. Data sheet understanding, mainly you have to see this one, data sheet understanding. So initially you have to study any, if you are starting with any microcontrollers, first of all you have to understand that particular data sheet, user manuals, those system files. If you some of them have already predefined codes, they have there is not a fully code, there are some bare code or some raw abstract they will give. So you have to understand that code, and you will implement your application code on the based on the application means whatever the total out, like you're controlling some motors, fans, lights, everything, those are all come under the application code. So these are the tools we are using for the editor. So if you want to write a code means what you will do, basically you will do like you will choose these kind of things, and you will write your code, like but in industries mostly they will use for Keil IDE, Eclipse, like Visual Studio. Most of them you might hear these names. So Altium is like a hardware schematics, like these are for this is for a hardware design. So Polarion is like a, for the documentation purpose they will use. So in main MNCs they will mostly prefer documentation before you do the code, before you do the any work. first of all they will write they will do documentation and then do their work only. So this is what mainly tools we are using for writing code we will use. And for debugging purpose there will be another things like a jailing GHS. There will be another tools are there for the debugging purpose. So and then what we'll have for the real time. So we'll see some example for the real-time systems. Like if you see the cruise control systems, so this is what I said, like automatic self-driving cars. Nowadays it is a very huge, like in every car we can see these cruise control systems. Cruise control means like we are automatically self-driving cars only. Cruise control means we are giving the control to the embedded device, so it will control all your speed increasing, speed decreasing. What are all the like I said, so initially you have some abstract what you have to do for the particular system. So cruise control system you have to drive the car. If you give the control to you, so you have to drive the car, you have to maintain particular speed, whatever speed he had set, and you have to drive your car. So what are the some things in you can see in for the cruise control system? So adaptive cruise controls automatically adjust the vehicle speed, so maintain the safe distance from the vehicles ahead. So in front of your vehicles, some vehicles are there, so it will automatically see. So it will in front of this some ultrasonic sensors, some proximity sensors will be there, and there will be some cameras or image processing also they will do. So based upon that there is a, even if you're designing any system, there will be a safety system is main things. So even you're going in a high speed or not, they won't matter, but it should not affect uh, any of the people's life. Like if you should not hit anyone, right? Like suddenly if someone is going, you should stop, you should press the brakes neatly. So those kind of things will be there, safety mechanism. So line departure warning. So if you give control to some cruise control, so if you're driving it selfly, if you are, so there will be a lines will be there in on the road. You can see the lines, there will be a white lines on the highways. So it should always you can see your line follower robotic. If you see the robotics means some line followers will be there, right? So it will always follow that line. So if it is deviating from the particular line, it will automatically inform to the what driver, like yeah, your car is like going out of the way, like that it will take. So emergency brakings, I said you, right? If anything, any vehicle inside in front of you, it is nearing, it is approaching you, you have to press the brake, it will automatically press the brake. Any blind spots, like it is any holes or in the on the roads, any holes are there, it will slow down the vehicles. Like that, any pedestrian detection, like in front of people are walking in front of you, your car, parking assistance, even though you can see this parking assistance also will be there, like backside cameras will be there. If you see cars, there will be while parking, it will intimate like out backside some people are there, like that it will intimate automatic parking, it will do. So traffic sign recognition, so even in traffic it will detect the signals, like yeah, you are in green, yeah, you can go now, yeah, you are in red, you have to stop now. These kind of things, these cruise control systems. So basically this is what how they will design. So like if you see this, these are all the requirements. As I said initial, these are all the requirements, these are all the fulfillments you have to do. These are all things like the, these your embedded system should work under all these cases. Like you have to brake, you have to follow the line, uh, you have to see the pedestrian detection and parking assistance. These are all should be there in your embedded devices. These are all like a requirements for your. You have to fulfill all these things in your embedded devices. So if you see your cruise control means, so it is install, basically it will install in your steering. So after that, embedded system is not like a single embedded devices will be there. Like it will be a bunch of, it is a collective of embedded devices, and it will all connect to some central devices. So some central monitoring device will be there. So that will take own decision. So inside that, some particular small embedded devices will be there. It will communicate to one another. So if you see the cruise controls, there will be a steering wheel control. So even for the wheels also, for the turning also, for the wheels, how much tilt it is rotated. Those kind of details also it will take from the vehicle. So what is the steering position, how much degrees it is rotated, at now how much degrees it is rotated, like that clutch switch. So it have the control of for the clutch and brake control also. So all those things it will take the control of this. And whenever you have some data, throttle valve, and means so you have set for some particular speed 40-50 kilometers per hour, if you set for the things. So it be in front some vehicle is there, you have to slow down your vehicle. So you have to go to some 20 kilometers per hour. Again, it will what it will do, it will check what is the current speed, it will check, and based upon that it will press some brakes and reduce speed. uh, like that it will take the control. This is like some example of embedded system devices. It is like a single device. Like if you take steering, there is also braking system also inside that. Also some logics also will be there inside that. Also some embedded devices they might include. So this is how some embedded system or embedded device. These are all the things will do on the project. Things are inside the some industry. Some any work will be assigned. Like this is all the basic flow. Once you entered in the any industries, you might know these all things in your industries. You might know they will give work, but you have to what you have to know is basic things like what is microcontroller, what is microcontrollers. You have some knowledge on the digital electronics, and you have some knowledge on analog electronics. Basic study, whatever you are studying here, that you have to maintain it properly. So you have to study properly whatever you are reading. Those things only. C programming, whatever you're learning in C programming. So the C programming is the base of the any coding things. So if you see the career opportunities for the particular embedded systems, there will be a two career options. There will be hardware things will be there, firmware will be there. So hardware means it is like a building. So you have to build your system. Like if I check the if I take these requirements, you have to build some steering kind of things. For this, I have some switches I have to interface, some devices, some controllers I have to choose. For that controller, some power circuits I have to design. These kind of things all will come under hardware. So there will be some power circuits will be there, some microcontroller circuits will be there. If you have the engine or any uh, motors are there, you have to control those things. For that, there will be hardware design will be there. So for those kind of things will be under this hardware career option. Like if you choose a hardware means it is a completely hardware thing. Like it won't involve in any coding details. It is like if I say it is like a some our entire analog electronics thing. So if you see some transistor controlling some transistor switches, you can see the like, controlling some LEDs, some motors. You can design some. So those kind of things will be under a hardware thing. So in also hardware, there will be separate roles like architecture role will be there, design engineer will be there, verification engineer will be there, test engineer will be there. So nothing is small. Like architecture is high, like a verification. But whatever if you choose to, you have to love to do. You can choose your own profession. Don't like my friend is taking a he's architecture. I am a developer, just a designer. So I have to go to the architecture. Don't do these kind of things. Just whatever you like, whatever you like the most, whatever you have the interest, you have the passion on that, then you can choose your own profession. Architecture means basically they will take the whatever the requirements they have, then they will do those requirements, and they will just freeze these kind of circuits. I have to you have to design those kind of things they will do. And design engineer will do the you will he will make the circuits. Like if you control some fan, so there will be some circuit will be like this. Some power circuit, there is a some 10 to 20 electronic devices are there, electronics, like a sensors are there, controllers are there, actuators are there. So for these all these things, I need some power. There is a power circuits also will be there. These kind of things, circuit design will be done by this design engineer. After this design, so whether this circuit is working or not, that will be tested by some verification engineer. those kind of things. This test engineer ultimately final product they will test, like whether while sending to the customer, before the customer they will test the whether the particular device is working or not. This is a normal regular work on the test engineer. Mostly we will choose for, if you choose for hardware, these will be like circuit designings will be there, and we will implement those things. So in this only some schematic designs will become. So after that there will be a firmware engineer will be there. So this is what mainly we, from our faculty, most of them people will go for the firmware main role, developer role. They will go most developer and verification are at the same level of this. Packages also will be like the same only, almost equal. So architecture means after development you have, if you work for some 10 to, if you have the more than 6 7 years experience or 10 years experience, then you will be like some architecture role, some staff engineer role. Those are like instead of writing more code, they will design the how you have to write the code. So how if you want to write the, it is a big system, right? So there will be a code will be, they will divide it as a modules wise, like they will divide a small codes and they will assign to people, and they will this kind of work, how to divide that code. So how to divide that code and how to integrate that code, those kind of architecture level things will be done by the firmware architect. And then developer will do the coding. After the architect will do the, if you have to do these coding types, so you have to develop the code. That is all the developer will do, develop and they will do basic testing. After you develop, this developed code is tested by the verification engineer. These engineers also they will write code to test your code. So this is when the, like a scripting things, like it will use a Python like things they will use, and they will automate your automatically they will test your code. This testing error, as I said before releasing your product, it will be like a this testing error like a both like a, you will deliver a, not only code, right, you will deliver hardware with your code. So this testing engineer will test the total functionality, whether your uh, whether your product is totally working or not. He will check and he will, so what are the skills required for the particular roles you have. So mostly I will tell in point of view the firmware. So whatever you choose, basically you need these in embedded systems. You need these basic skills like programming skills. Yeah, so you must have the C programming skills. Basic C programming, basic, not only basic. You have some more experience in C programming. Assembly also it might required. You have to understand the assembly. That's it. That is fine. It is not an exam, right? We can remember the things and you will write it. So you can in your office you can easily see the instructions and you can write the code. It is not like exams, right? In the for the but C programming you have to, you before entering to the any industry, you have to know the C programming skills, like a functions, structures, algorithms, like these kind of pointers things, union structures, these kind of things you might know, and some practice some programming things. And embedded system concepts, like whatever I said, for controllers, you know the any controllers, take that controller. So that controller things only we have to check. Any controller, you can take any controller. So you have the basic knowledge on the any one of the controller. I am not saying that you have to learn some LPC control, RAM control. Any controller you have that you can do. Even if you see the Arduino board, there inside that they will have some controller. You can see that the Arduino schematic. If you are working with some Arduino board or any controller boards you are working, and if you check with that particular details of the particular board, there you can see some controller inside and some sensors inside, some communication peripherals inside. So yeah, observe those things, basic things. Those are, so though you need those kind of things. Some hardware knowledge means hardware knowledge, not big these kind of things. Hardware, what are the controllers, what are the sensors, what are the actuators? You have to differentiate these things. This kind of knowledge you have to know. And also hardware knowledge means some circuit designing skills also better. It is better. Some small scale industries they will use you for hardware design and firmware both. They will, you have to do the both works. Like you are not like I only do the coding, I won't do the testing, I won't do the hardware design. No, nothing like that. Some if you go to the some small scale industries means they will do all, you have to do all the work. So you have to basic knowledge on the analog electronics. Uh, so digital electronics also needed, very much needed. Okay, some state missions will be there, right? So those are all mainly using for firmware coding, and even for the hardware also they will use for some flip flops, clocks, those and all things. So software development tools. So IDE mainly you can see IDE. IDE means Keil, Eclipse. You can see this basic one or two tools. Whatever you know, whatever you think, but at least you have to know the some tools. Tools is for like editing your code, like those kind of things. So communication tools. Communication tools means uh, if you trace any like TCP data, like those kind of things. Uh, Communication tools means whatever the communication, even from the Wi-Fi, Bluetooth, whatever the tools, we have some tools to monitor those things. If you see any internet, if you accessing any internet, if you install Wireshark, means it will trace all the data, whatever you are searching, it will trace all the data. Like that, some communication tools will be there. So you have to use those things. Problem solving things. This should be must. So you have to debug if you have the any issue, if you're writing the code, or else anybody read the code and they give you to trace out some problem inside this, you have to see the what is the problem, you have to understand the problem, and you have the knowledge of the basic debug. But these are the problem solving and all, after going there, yeah, you will know this kind of things, no need to bother of things. As of now, you mainly focus on your programming skills and microcontrollers and their peripherals, what are all the basic codes, and for the controllers you have to know, and you have to much more knowledge on the analog electronics for the basic only, not only designing the big things and all that. So yeah, at least you know basic switching circuits of using a transistors or MOSFETs. Yeah, at least you have to know these basic designs. So digital electronics, you must know the basic concepts of these gates and all, gates, clocks, flip flops, everything you have, counters, registers, these kind of things, state machines are there. So this kind of all digital things you must know these things. These are whatever you're studying, study focusedly. Those only we can say in interview, any interview you can face it confidently. You can say whatever you know. So don't be like if you don't know, you can say I don't know, or else you are not studied that. Nothing is like you don't know, like you don't study that, like. So you can say that I have not covered and I can see I will learn, like those kind of things you can say. So whatever you know, up to that you can perform. So this kind of the skills mainly we will see. And I think this is only this is only what I have. So, to cover anything. So okay, this is all we'll have. This is how codes will be there in industries. Like it will be like a not only single, not only like a our simple program. It will like a. It is also like a functions only. But this is all you will know. But at least you know the how to write a function. How to write inside some functions. You have to know. So how to, so these are the basically, if you see all of these arrays only functions. So this is the industrial code only, industrial level some code only, like if you see target somewhere, this is for the cruise control, what I said, for like you can control some velocity, so vehicle task, so whether vehicle in which speed, whether it is going in. So if you see this, all are if else conditions only, while conditions only, functions. So basically, what you know is you have to write so many codes. So like programs, you have to practice. You have to practice programs. Those kind of things only you will see. So mostly you will see any of the new things, any magic, new magics will be inside the any project or any code. So all of the things are switch cases, functions, these kind of things only. So there will be multiple C files will be there. So they all will be compiled and they will be generated. So this is what will be do. So any questions and answer I can take the extra 15 minutes. Okay. Yes. Okay. Okay. Check. Okay. As a embedded systems. So embedded systems. So yeah, we have faced so many issues like those kind of things. We can suppose if you take any system like uh, any embedded devices, if you take like if any Bluetooth device or a Wi-Fi device. So basically, how you have to debug is like whether you have to acknowledge that system like so your controller is connected to some Wi-Fi system. So that is a separate module. So there is no communication between your Wi-Fi module and there is a controller. So how you have to check like means there will be a so you have to test, you have to trace out those things like you can use a oscilloscope. There will be a another other tools like we have a debuggers kind of things like you can see some things like if you see the here like so using debuggers we can check like if you see this code I put this in a debugging mode. Like I will start this code. So even I will check. So our firmware is like it is like a C code only, right? So this is basic example I have seen. So why I am not telling the exact scenario means you might not understand or not. So basically we have some debuggers like this. So you can go inside your code, and if you have any issue inside that, you can go step by step into each of the line. Whether if you see here your data is updating here, you can see all the variables, whatever your function you are writing, what are the prints you have, those and all you can see here. So most of them you might not know or not, I don't know, but this kind of thing. So you're using some debuggers or something, we can use this, and you can use some oscilloscopes to trace those data, like whether whatever you're sending that data, that is reaching to the ultimate your controller or your Wi-Fi module. These kind of things you can check. So there is also some tools for, so for wireless communication and all, there will be some tools like a Wireshark will be there, like this will be tool for the track the. So mostly I worked on the this wired and wireless technology only. This tool is used for like trace all the networking things. Like it will, if you see here. So if you see here, like you can check all your whatever data through the wireless communication. You can see here like Wi-Fi or Ethernet you are using. You can see all the data from the particular IP. So whatever you are using some module, there will be some IP address they have that you have to put. So whether you can have the data or not, you can check here. Before that data that is coming from your Bluetooth module only, right? Even that is not coming to your server or your software, means you can trace from the hardware only, hardware itself. So you can use some debugging, some oscilloscope, you can trace your logical things. Most of them you can ask specifically like what are the techniques, means instead of that you can ask what are the particular thing you have. You can ask specifically like if you faced your problems in your board, like initially startup only it is stopped like at the assembly level. Those kind of things you can ask. So mostly we will use some debuggers. There will be a J-Link debugs will be there, GHS debuggers will be there. So based upon that we will go with those things. Mostly we'll use debugging, those kind of things. There will be a logic analyzer will be there. So that logic analyzer, if you can directly trace your all I2C or UART, ITC data, UART data, all those things you can see in your software tool. There is always some software tools will be there, some hardware equipment, debugging equipment will be there, like logic analyzer. So if you connect to some logic analyzer to your embedded device, and there will be some software tool available for the particular logic analyzer. So you can see all the data there. If you are not getting the data, either that system might be in a off state, or that device had some problem, or the particular communication had some problem. or that circuit, whatever the controlling circuit or the data path you have, you can see that. So you can step by step you can go like that. So first of all, whatever you're sending from the microcontroller, that is going to your Wi-Fi module or not, that you have to check first. So if it is going if you are seeing those data on those lines, you can check with the oscilloscope or logic analyzer. After that, if it is reaching to your Wi-Fi module, means Wi-Fi module you should acknowledge. Then you have to check for the acknowledgement. So if it is acknowledging and you are sending your data to the Wi-Fi module, and now the phase is like that should reach your system, like your system is your whatever that Wireshark I said, that Wi-Fi module should send to the your Wireshark. So that is data is not coming or not. So at this level, even that Wi-Fi module is also sending that data, means there will be a some IP address routing or so if you go to the companies, means they will restrict your IP address in your systems. So you have to contact your administration team, like whether some particular IP I'm not getting the data. If you are you blocking that particular IP, these kind of things will be there. Most of the things will be like this only. Even for even for you what I2C peripherals, SPA, these kind of things, you have some logical, using some logic analyzer and the oscilloscope, you can check with the any of the things. Any other questions or anyone? Only one question from Bhavita Kadiri. Okay, anyone understand? Are you able to understand? I think most of them I skipped. Uh, Due to lack of time, I skipped. I want to morely cover on the what are the your roles, how you want to prepare, what you want to prepare. These and all I have. So okay, you can you can speak, Surya. I think we have. Which one is? Can you repeat the question? Um I think mostly that will depend upon the whatever the sensor you are using. So nowadays, even the digital ones also, it is a more accurate and with it is coming with a low cost. But is what are the thing is like if you are doing for the budget things, then you have to go for the whichever it is low for the analog is the more accuracy it will do. But whatever the issue with the analog things is. You have to give the more work on your code. Like if you are reading analog things, means you have to make some accuracy with the terms. So you have to prepare so many like you have some, you have to collect some data for the analog things, and you have to check some range. So digital means it will directly give the some value like 30.4, 30.5. It will directly some value, but analog means it will not be like that. So it will have the some variations in the, so it will give in a voltages, right? So that voltages you have to convert to the normal thing. So for that cases you have some more processing in the analog things. So if you want to if you want some cost reduction things all are there, you can choose for the some analog things, and you will do some more logics in your code. You can put your more logics. But what I suggest is, like, you can based upon that is your so the total overall cost of your embedded device. So you can choose either analog or digital. That is your cost dependent. But you can choose either of the things. But whatever the thing is, you have to choose the either you have to choose analog, means then you have to implement some more code in your firmware. That is what I feel. Any other? Yes. Which has more accuracy, either analog sensors or digital sensors? Uh, we can't say like which one is accuracy. Like it is depend upon the product they are delivering. Like a sensors vendor, it is depend upon the sensors vendor they are providing. Like some of the sensor they will providing with they will say some 90% accuracy, 92% accuracy. They will say with even it is a digital or analog, they will say with some accuracy. So I will give it this particular accuracy I will give. So those kind of things they will mention for the particular sensor. So it is not about the analog will have the more accuracy, digital will have the more accuracy. But if you see the digital sensor, it is already processed inside the sensor, and it will send the digital data to us. When it comes to analogous data, so it will take the data and it will give in an analog manner. So there is some small variation in that, but I will I'm not saying with analog is bad or digital is bad. The both are like a same only, but accuracy is it is depend upon the who are the manufacturer. It is the manufacturing that particular sensor. Mostly you can prefer digital if you do for the more accuracy, or if you don't want to integrate more the things hurdles. Okay, any other questions? Yeah, what are the I'm not listening any questions from these students. Yeah, you're not understanding these things, or it is not internships. Okay.